Recording in.
Hi, everyone. Welcome. We'll give everyone a couple of minutes to arrive and then we'll start. Okay, well, it's 7:01, so we're going to get started. For those of you who are joining us, my name is Joanna Roche. I'm the Executive Director of my Mariah Mitchell Association. I am here tonight with my esteemed colleagues on Nantucket, who I hope I do justice to introducing in a few moments. But let's just start by welcoming everyone who's in our viewing room and saying that we're going to talk tonight about our harbor health, which is a collaborative approach to water quality monitoring on Nantucket. And so tonight we have five speakers who are going to share with you a little bit about their role in our project. And I wanted to start off by saying that I think this is probably one of the most exciting projects on Nantucket right now, partially because it is a collaboration between 5, 6, sometimes 8 different groups and organizations with a common goal of improving harbor health. And that in and of itself, I think, makes the project unique and extremely special. And so I wanted to start this off by thanking all of the folks who are speaking tonight, and Janelle, who helped us get this all set up, Janelle Gurley, who's our Program and Science Director here at the Mariah Mitchell Association, and the donors who made our buoy possible and who will continue to help us fund different programs like this. Most specifically, I'd like to acknowledge the Great Harbor Yacht Club Foundation, who has been extremely generous in supporting all of our organizations and also in bringing us together to work collaboratively. So thank you very much, Great Harbor Yacht Club Foundation. Okay, so let's get started. And what I'd like to do is I'm going to introduce each of the speakers. So you'll bear with me because I'm going to share with you their bios, but I want to make sure that I do that so that everyone in the audience really understands the depth of experience that all of the folks on this panel have. Not only the depth of experience, but their commitment to Nantucket water quality, which I think is personally, I think is exceptional and worth noting. So I'm going to start with Tara Riley. Tara, maybe you'll just wave. Hello. So Tara is the Shellfish and Aquatic Resource Manager for the Town of Nantucket Natural Resources Department and the Brant Point Hatchery. She obtained her degree in marine biology and master's in fisheries and aquaculture. She's had 25 years of experience in the field of producing saltwater fish for shellfish research, profit, and now restoration. She has been involved in regional and global hatchery renovations, served as a consultant for WHOI for the development and operation of a hatchery in Zanzibar, Tanzania, and she came to Nantucket in 2009. Tara has worked on the development and implementation of shellfish enhancement initiatives and water quality and habitat monitoring for Nantucket Island's waters. She has gained enough community support and stakeholder buy-in that she was able to secure funding for the $2 million design and renovation of Brant Point Shellfish Hatchery, no small feat. And as a hatchery specialist, She has been involved in the development of the town's first shellfish management plan and now the first eelgrass management plan, which I'm sure she'll talk a little bit about both tonight. She is passionate about everything related to recreation and commercial fisheries and strives to create a more sustainable and healthy future for Nantucket's natural resources. Welcome, Tara. And we also have with us Emma Morgan. Emma, if you would just give a quick wave to everyone. Emma is the water resource specialist for the town of Nantucket's Natural Resources Department. Morgan earned a bachelor's of science in biology from St. Mary's College of Maryland, followed by a master of science in applied coastal ecology from the University of Central Florida. Her job on Nantucket focuses on managing the town's water quality monitoring program, which involves sampling the island's recreational waters, monitoring harmful algal blooms, analyzing water quality data and trends, and collaborating closely with science organizations on and off the island to maintain the health of Nantucket's water bodies. Welcome, Emma. And then we have Dr. Rich Blundell. He is the visiting scientist at the Maria Mitchell Association. Rich, give everybody a wave. And he is an ecologist and philosopher working at the convergence of art, science, nature, and culture. He is the founder of OICA, and his research examines how transformation happens across the scales of person, place, and planet. Rich is a communicator. He tells scientific stories of the universe that includes art and human creativity as natural phenomena. Dr. Blundell's research and work has received numerous grants and awards, including an ongoing Tides Innovators Award, the National Science Foundation Grant for Science Out There, the Michael Brinkman Award, and the Deep Time Values Video Award for An Earth Story. Rich's work has also appeared on PBS, National Geographic, and numerous social media platforms, and he, again, is working with the Maria Mitchell Association as our visiting scientist. And thank you, Rich, for being here. R.J. Turcotte has worked for the Nantucket Land and Water Council for the last 6 years as the first resource ecologist and then as the Nantucket Waterkeeper. R.J., give a wave. And he started his career in Rhode Island with Save the Bay and the Blackstone River Coalition, assisting with the salt marsh restorations, environmental education, and heading a volunteer water quality lab. As waterkeeper, he works on eelgrass restoration, water quality monitoring, coastal resilience, and environmental advocacy across the island community. And last, we have Charles Johnson. Give a wave, Charles. Hi. Charles is the stormwater manager for the town of Nantucket Sewer Department, and Charles has recently been asked to oversee the town's stormwater system for the Nantucket Sewer Department. He's been working there for about 7 years as the treatment plant operator and engineering compliance officer, and for the 17 years prior to being on Nantucket, he taught mathematics, tech education, boat building, and STEM classes to high school students in New Haven and Bridgeport, Connecticut. During that time, he's also been a sailing coach and started a girls' ice hockey program. And then he worked formally as an environmental engineer, first with the DEP for New Jersey and then Connecticut, and then for private consulting firms. He has been coming to Nantucket since 1970 and is, I think, quite happy to live here now. So welcome, Charles and panel. And I think we will now sort of get started with our presentation. And let's see, I think, Janelle, are we ready for the first slide? So I think that before we get to the speakers, what we'd like to start with is just an understanding of what collaborative water quality monitoring in Nantucket Harbor actually means. And, we really are seeking, one, to create a meaningful collaboration between all of our organizations, but also to really affect change in our community. And I think our common goal here, both in the project that we're going to be discussing and in our presentation, is to really start to be able to communicate with our community why these things are important and how we can live in a space in our community that sort of honors these values. And I think that that's important for us to acknowledge because Nantucket has a very long history of people living in community with the ocean, right? And I think that what this project will allow us to do beyond pH changes and understanding the impact of nutrient loading, it is crucial to understand the health of the harbor and figure out how we can mitigate the effects on eelgrass and the bay scallop. And one of the hallmarks of this project is that we can receive constant real-time data, we can observe water chemistry, and we can start to analyze the effects of these fluctuations and also to make recommendations of things we can do to preserve our marine ecosystem. Okay. Janelle, I think we're ready. So why water quality monitoring? I think what I would like to do is sort of turn this over to Rich, who is sort of leading the effort for the Maria Mitchell Association, at least, and working with all of the great people on our panel. But I'll let him talk a little bit about why we're doing water quality monitoring. So you can take it from here, Rich.
Okay, great. I'll speak about the data that I'm presenting later, but I guess I would just say that, like you said, Joanna, it's really important because we're a small island in the middle of an ocean with a big bay that's central to, so much, pretty much central to everything about life on Nantucket. And I'm giving a talk later. It's called Measuring What Matters: Water Quality of Life. And I think that kind of the fact that we can sort of converge the term water quality and quality of life, I think that's just a way of sort of signifying just how deeply connected we are to the bay and to the water and the quality of the water. And as you'll see when I present my data, that Nantucket is unique for a lot of reasons, and the water quality doesn't escape that. We have this incredible opportunity to do something profoundly impactful in our community, and to see just the brain trust and the commitment that's in this project from all of you is just really inspiring. So I guess that's what I would say as to why we're doing that, because it's central to our lives out here. And the other thing is that we have an opportunity here to be a model for this tiny little island, to have a big idea and to carry it forward and be a model for the world, really. And I'm not just saying that. I really believe that. And we're at a moment where the data, the quality of the data that we're getting is going to empower us to make some really wise decisions about how we go about doing that. So I guess that's how I'd kick it off.
Great. Okay.
I guess I'm on.
I guess you are. Thank you, Charles.
I'm Charles Johnson. I'm the stormwater manager, and I also I'm still associated with the sewer department. So I'm the engineer for the sewer department, which will be important over the next few years, and I'll show you why in a minute. Next slide, please. So the Mass DEP has been looking at the nutrient loading in Nantucket Harbor for almost 20 years now. They've realized that the nutrients limit the eelgrass growth, and any overloading of the harbor with nutrients is detrimental to those beds. Next slide, please. So back in 2006, the Massachusetts Estuary Project, it was a joint between Mass DEP and UMass Dartmouth, did a study on the Nantucket Harbor, the bathymetry, how the flow of tidal flushing in the harbor. And they took a look at some of the loading that's controllable by the town. And those include stormwater runoff, impacts from septic systems, and fertilizer. And they came up with some recommendations. Next slide, please. So 20 years ago, they recommended that direct discharge of stormwater to the harbor should cease completely. and that all runoff from impervious surfaces should be discharged to vegetated surfaces. So using vegetation to treat the nitrogen and allow the stormwater to infiltrate to the groundwater. Next slide, please. They continued looking at the harbor, and they came up with a TMDL, a total maximum daily load estimate for nitrogen in 2009. So 15 years ago, they established limits on nitrogen loading into the harbor that could be controlled by the town. Next slide, please. And they came up with these limits on the different basins within the harbor, and those loadings came from wastewater, including septic systems and stormwater and other impacts. And so they put a limit on the nitrogen that could be put into the harbor without degrading the water quality. Next slide. So in 2022, DEP came and established nitrogen sensitive areas. There are two colors on this map. The dark green is on the Cape. Those are established nitrogen sensitive areas, and they established new regulations for Title V, which regulates septic systems in the area. And it mandated upgrading of septic systems to these IA, innovative alternative systems, to limit the nitrogen that was going into these nitrogen sensitive areas. And you can see that Nantucket and the Vineyard and Buzzards Bay is shaded in a lighter green, showing that these are areas that DEP may regulate in a similar way for nitrogen in the future. Next slide, please. This January, DEP came up with a new document, a non-point source management plan, which outlined what they want to do over the next 5 years. Next slide. And they came up with a new map, which now enables Nantucket to apply for funding for some planning grants, which would take a look at the loading of Nantucket Harbor. Next slide, please. And included in that would be a watershed plan, and you can see in the shaded area to the right, in 2027 or 2028, they are planning on having Nantucket have a watershed plan, which would outline all the loading into the harbor caused by wastewater, stormwater, just atmospheric deposition, and that's an alternative to having all the residents in the watershed area upgrade their septic systems to the IA systems. So the town would take the responsibility on tracking the loading into the harbor and limiting that to those TMDL levels. Next slide, please. So last year, this is on the stormwater side. So this watershed plan would include wastewater impacts loading into the harbor, and we need to revisit the loading caused by septic systems and possibly make planning for sewering different areas, some sort of like what we did with the Shimo area over the last few years, to limit those wastewater loading. But in last year, we came up with a sampling program, and again, this shows the collaboration between the town and Nantucket Land and Water Council, the Mariah Mitchell Association, Nantucket Shellfish Association, and the Great Harbor Yacht Club, who contributed money to buy the sampling equipment. Next slide, please. So the plan involved sampling 5 outfalls over 2 years. It likely will continue after that, and sample 10 storm events year round, and calculate the pollutant loading, both for nutrients and other pollutants from stormwater into the harbor. And it's important to establish a baseline for that loading in order to see how that is comparable to the TMDL levels that the DEP has established. Next slide, please. So we're looking at 5 sampling sites, the major outfalls of stormwater into the Nantucket, the town basin. And next slide, please. So the sampling equipment includes composite samplers that will be sampling from these outfalls. Next slide. Along with flow meters inside the pipes of the outfalls. And those 2 things combined are important because, next slide, please. We need both of those to calculate the loading. So the loading is a weight over time. And so we need both the concentration that from the sampling as well as the flow measurements coming out of the outfall. Next slide, please. And this is one of the sites, the Washington Street extension site. It's the site of where a constructed wetland was installed around the early 2000s. And that's, it was installed to treat the stormwater before it was discharged into Nantucket Harbor. And it's an example of green infrastructure that we'd like to put into other, some of the discharge areas. Unfortunately, this was not maintained, and it is completely overgrown with Phragmites and needs to be restored. And we plan on doing that this spring. So the baseline that we measure on the initial sampling will be used to calculate the efficiency of the nutrient removal from that constructed wetland over time. So after it's been reestablished, we'll continue the sampling, and we can see how effective this was. Next slide, please. The parameters that we're testing for are some oxygen demand parameters, metals, and then the nitrogen series, oil and grease, phosphorus, and bacteria. So the bacteria is important in terms of seeing a relationship between the beach closings, such as Children's Beach and Francis Street Beach, Jetty's Beach, and see if we can trace the bacteria sources back through the stormwater and eliminate those sources. Next slide, please. So the stormwater is part of the impaired water body Nantucket Harbor is right now. It's definitely a major source of nutrients. So that's on the stormwater side. We'll also be looking at on the wastewater side, getting an estimate of the wastewater loading into Nantucket Harbor. Both of those combined will be looked at, and it'd be part of that watershed permit and the plan that we have to put together for DEP the next few years. So that's where things are headed. I think it's important that we continue this collaboration between town departments, we definitely have to talk to the health department in terms of septic systems, natural resources, in terms of monitoring and come up with the loading for that watershed plan. But that's where things are headed.
Thank you, Charles.
Yes, thank you, Charles. I think we're ready for our next speaker, who is Emma Morgan.
All right. Thank you, Joanna, for the introduction. As she said, my name is Emma Morgan. I'm the water quality specialist for the town, and today I'm going to be talking through the Natural Resources Department's water quality sampling program specific to Nantucket Harbor. So going over sampling, monitoring efforts, data analysis and reporting, and then collaborations to finish out. Slide, please.
Coming.
Thanks. To start off, looking at a map of Nantucket Harbor, just to give everyone an idea of the reach that our department has for sampling. These are all of the town's water quality sampling stations. The blue dots, or anything with NAN in front of it, are the stations that have been sampled since 2010 every year, once a month from June to September. And then the red dots, or anything with SUP in front of it, is a new addition to our sampling routine that we developed with the Nantucket Land and Water Council last year to identify nearshore areas in the harbor to monitor, in addition to our sites in the channel, in the interest of monitoring eelgrass health a little bit more closely. So the first year that we sampled those sites was the 2024 season, and then we plan to continue this effort this year and in future years, also with the same frequency. Slide, please. So getting into what our sampling routine looks like, not in too much detail, but we travel to all of those sites from the previous slide once a day, or once a month on one day. So we measure depth of the water column at each site using a Secchi disc. So the bottom left photo to measure water depth as well as clarity. And we take a 1 liter sample from the surface of the water and the bottom of the water column using a Niskin bottle. So the bottom right photo to trap water from the bottom of the water column. And then we take abiotic measurements using a YSI meter. It's a fancy water quality measuring tool on the top right. So we use that to measure water temperature, dissolved oxygen, salinity, conductivity, and pH. So basic abiotic parameters to kind of measure water health. Slide, please. After all this, we filter all of our samples into smaller bottles for specific nutrient tests that we ship off to our water quality lab in New Bedford to do specific nutrient assays on. And our water quality lab that I'll talk a little bit more about in a second is the Coastal Systems Lab through the University of Massachusetts, Dartmouth. So they process all of our filtered samples for this suite of nutrients that you see there on the left-hand side. This is where we get data for nitrogen, phosphorus, chlorophyll, carbon, things like that, nutrient levels in the harbor. And we pay close attention, especially to nutrients like nitrogen, because you'll hear a lot today. It's definitely an essential part of a healthy coastal environment, healthy marine environment, but we know that too much of it degrades water quality, can reduce water clarity by increasing populations of harmful algae that feed on it, as well as macroalgae, and it ultimately will harm eelgrass habitat. So sources of nitrogen from humans are yard fertilizers, broken septic systems, road runoff. Those are all really big human contributions that can negatively affect nearby water bodies. So when we look at our nutrient results, we tend to focus on total nitrogen values. Slide, please. So Charles went into great detail on this, the Massachusetts Estuary Project in 2001. So estuaries in southeastern Massachusetts were assigned nitrogen loads to determine where they're necessary reductions by giving them a TMDL, so total maximum daily load, which is a state recommended maximum amount of a pollutant that a water body can contain and still support a healthy ecosystem. The TMDL assigned in that study for Nantucket Harbor was 0.35 milligrams per liter of nitrogen. And just looking at last year, 2024, the total nitrogen for the harbor as a whole was 0.32. So it's looking good. Since we're below that TMDL, that indicates we have pretty good water quality. And so we're doing pretty good on that scale in terms of not getting over on that nitrogen amount, and that the efforts that were being made by all of the island organizations involved in harbor health are definitely having a positive effect. Slide, please. In addition to all of the data and nutrient processing. The Coastal Systems Lab in New Bedford also compiles really great summary reports for us every year that we post on our website. The QR code there, if anybody wants to scan that, will take you to the page. And then after this talk, I can also put them in the chat. So this is a really important component of our program that I wanted to highlight because this the analytical lab in New Bedford samples from all over, processes samples from all over the Southeast Massachusetts region, so Cape, Islands, everything. And they're state accredited laboratory. They processed our samples every year the same way since 2010. And this is really valuable because consistency in their sampling and processes means that we have almost 15 years of data that are comparable from year to year. So this makes it really easy and really reliable to identify long-term trends in water quality and overall harbor health. Slide, please. This is a fun one. I love this figure. So another metric used by the Coastal Systems Lab is a trophic state index. So this is just a quantitative measure of nutrient-related health, typically based on a number of water quality measures, like the ones that I mentioned at the beginning. So it's a way to boil down a range of factors to one characterization. And we do that by taking all of the measurements that I previously mentioned, DO, temp, Secchi, depth, salinity, etc. And then we use that to kind of figure out how the harbor is doing in terms of a trophic state. So this particular figure shows health from 2018 to 2024. So each line of triangles, the top triangle is going to be 2018, and then the bottom is 2024. And then looking at the key on the bottom right, blue indicates strong water quality, which makes up the majority of the sites, which is great to see. And then with the exception of some yellow areas up in the head of the harbor and then in Pulpus Harbor. And this kind of makes sense because these areas definitely get less circulation than other areas of the harbor. But as a whole, from our 2024 report from them, Nantucket Harbor currently has the highest water quality of all of Nantucket's estuaries. Slide, please. In addition to our annual reports, we also house a water quality visualization tool on our website created in 2018 through a collaboration with MIT Sea Grant. So it's a really great tool that allows anybody, member of the public, stakeholder, whomever, to visualize, download, and process the town's water quality data that we collect every summer back to 2010 for all water bodies, not just Nantucket. So any of the Great Ponds or Nantucket Harbor. It's fully open source and it's updated every year with new data. So again, that's the QR code for it. And I can also put the link in the chat in a little bit. Slide, please. Switching gears, I want to spend a few minutes talking about our long-term monitoring efforts. So in 2017, the town began deploying water quality meters during the summer and early fall in the head of the harbor and in Pulpus Harbor, because thinking back to that figure, we saw that the slightly lower water quality was concentrated in these areas, and we think it's due, to a lack of circulation. And so we wanted to kind of zero in on that and focus more on these areas in terms of dissolved oxygen and chlorophyll, because if we're getting less circulation, that's going to mean that there's less oxygen in the water to support scallops, to support eelgrass, to support any of those important factors. So these meters are left in the water for several months at a time. They take measurements every hour. And this is just a really fine scale form of measurement. It's really valuable to look at closer trends of interest like this in the harbor. Slide, please. So the data from these meters is much more fine scale than monthly measurements, obviously, because you're getting a data point every single hour. So if we're to look at a single month, for example, this is August of 2018, dissolved oxygen in the head of the harbor. So it's difficult to identify trends. It's great to look at and see that swath of data, but it's definitely a lot of data at once, so it can be helpful. Slide, please. To add trend lines like this. So this suggests that we're seeing maybe a slight increase from the beginning of the month to the end of the month. As we start to head into fall, we're definitely getting some cooler water. That means that the dissolved oxygen in the water is going to increase. So it's an interesting trend to look at, but it's also really valuable to kind of look at this year to year. So slide, please. Another way to look at this data is to kind of average it by month and compare it over a few different years just to see if we're seeing any trends, and kind of comparing it over different periods of time instead of just 1 year. So if we look at dissolved oxygen during the summer of 2018 to 2021, we can start to tease out some trends. So the bottom axis represents months from June to August going left to right. And then same with the years, we have for each month 2018 on the left and 2021 on the right. I'll note that there's no dissolved oxygen data in June of 2019. That's likely from a sensor error, but it's great because we have, other years to work with. Looking at July and August, though, there definitely appears to be a slight increase in dissolved oxygen from year to year, which is definitely a positive trend, but these are very minute differences. Slide, please. So if we go back to that monthly monitoring data that goes back to 2010 and kind of compare these side by side, we can see from our monthly sampling data that there does seem to be a trend of increasing dissolved oxygen in this area of the harbor. But you'd have to do more statistical testing to kind of determine how strong these trends really are. But this just really serves as an example that I wanted to highlight of how having like this large swath of data going back and from different sources can really help to compare and tease out trends to kind of answer a lot of our questions. Slide, please. And so to wrap up from that example, I wanted to talk about some of the projects and collaborations that are going on in Nantucket Harbor and that are supported by all the data collection I've mentioned so far and all of the data collected by all of the organizations represented here tonight. And we've recently completed a sediment transport study for Nantucket Harbor. This kind of to understand sediment movements and circulation throughout the harbor. We're currently working on a groundwater study, as well as continually updating the harbor management plan and harbor health plan. And then moving into kind of some future projects and repeating projects. We're proposing to have a eelgrass management plan written for Nantucket Harbor. And then we're also proposing to have Nantucket Harbor included in the new Southeast New England Program State of the Region report through the EPA. And lastly, the Nantucket Harbor scorecard, which was started by the Great Harbor Yacht Club last year, will be continuing on an annual basis. And that was all I had, so I will pass it off to the next person. Thank you very much.
Thank you, Emma. That was great. All right, RJ.
Thank you, Joanna. And this is perfect for me to follow up on Charles and Emma. So, next slide, or no, stay on this one. So I'm the Nantucket Waterkeeper, as Joanna so greatly introduced me, and I have the program under the Land and Water Council has a big range. So it's all in Nantucket Sound, and it's 5 nautical miles around the 3 islands, Nantucket, Tuckernuck, and Muskeget. So it's about 850 square miles. And basically, if the water falls from the sky, or it's under our feet, or if it's in a pond or a harbor, we've been out there sampling it at one time or another. Now, what's really nice is sampling the harbor over the years and a couple decades now has been the town's job, and we get to use all the beautiful data that Emma just showed you to try to do some projects in the harbor, which would be kind of like shoveling against the tide if we didn't know what was going on in the harbor to the extent right down to the nitty gritty of different nutrients and dissolved oxygen and all that. The projects would be running blind. So with that, we'll go to the next slide. So one of the things that we still collect on our own, and we're excited that the buoy Mariah Mitchell is installing will be able to do starting next year, is light and temperature. So light and temperature sensors are these little, they're called pendant sensors, and they're smaller than a credit card. You can see one on a blue piece of PVC in the middle photo. And then there's one on a piece of PVC, actually at the Shimo Pond parking area by a rock. I stuck it in the parking lot and told everybody not to hit it with their car when they were parking, going to the beach. But we'd install these all over the harbor, both in Nantucket and Nantucket Harbor really since 2018, to monitor light and temperature in the harbor and see how much light was actually penetrating down to where the eelgrass is, which is often a factor of nutrient levels because they're feeding phytoplankton, which are preventing light from getting as far down. These are a pain in the butt. You have to wade out. You can see in that photo, one of my best assistants is my dog Jet, but you got to wade out to a buoy you set up that's not attached to the light sensor. It is a couple feet away and strategically placed and anchored at a spot that won't shade out the light sensor and mess up your data. And you got to go get them every 2 weeks because you got to scrub them off. They have a big memory, and you could leave them out there for over a year, and they'd record every 15 minutes what the light and temperature in the harbor is doing. but they tend to get algae growing on them and it starts to mess with your readings. So you got to go out there and clean them off. And people tend to try to tie their boats off to these buoys, even if you got your name and organization and phone number on them, and they rip them out, they disappear. All sorts of things happen to these little sensors. Luckily, they're cheap. They're probably less than $100 each. So you lose one every so often. It's okay. It's not great, but it's okay. But it is much better to have it in a central location and be able to have some consistent data coming in. And I just have a graph in the bottom corner there just showing the blue line is the light. So you can see it go up and down every day. Sun comes up, sun goes down. Some days are overcast and you don't have quite as much light, not as quite as much lumens getting down. But and then you have temperature that's going up and down with the seasons as well. So that's some data that we continue to collect that we're excited that the buoy will be able to help us with making heads or tails of in one location consistently. We don't have to worry about going out there and seeing if someone tried to tie it off to it and yanked it with their boat. So that's awesome. Next slide. So we have two restoration sites in the harbor, and the first one for eelgrass restoration is down by Monomoy, down by Second Pier, and the second one, which we actually just wrapped up last year, is up in Fifth Bend, up near the head of the harbor, and they're both 2.5 acres. There's thousands of acres of eelgrass in the harbor that we're trying to monitor and try to track the health of. These are not intended to save the harbor. They're intended to spark these areas with growth that is in that Goldilocks area of it wouldn't have done it naturally on its own, but the water quality is good enough that it is possible for you to restore the eelgrass in these areas if the water quality data you're getting is good enough. So we carefully selected the Monomoy area and eventually the Fifth Bend area. But the first site was the Monomoy site. So next slide. So this is how we do the restoration at each site. It's a 1/2 acre and it's spread out over 3 years. Instead of 1, 2, 3, when we work with the state, they have us do year 0, 1, and 2. Don't ask me why they do that, but that's how they do it. And then we have transect lines, which are lines that run along that 1/2 acre in those two sites, and they plant we plant along them, and then we seed in these thirds each year. Next slide. So the eelgrass restoration site off of Monomoy, this is our successful one. So this bare area was actually shoaled over back in 2012, 2013. A big storm event put literally tons of sand into this area of the harbor and just buried the eelgrass, but the water quality was good enough. So we started restoration there and it's actually finished and it has all grown back in and we're back into the monitoring stages now. Next slide. So eelgrass restoration, that top left photo is one of our eelgrass managers who worked with us for a couple of years, Noah Singer. He is working on a transect line that's just a tape measure along the bottom of the harbor in the restoration site, planting bundles of eelgrass. The photo on the top right's at the hatchery where Tara and her team have graciously helped us run a tank where we put eelgrass seeds in for our seeding efforts. And then that bottom photo is a bunch of volunteers working with us to fill tea bags half with sand and then with 10 to 100 eelgrass seeds each. And we go and we drop them in the restoration areas in that pattern I showed you earlier. It's quite a lot of work. Next slide. And lastly, I included this photo. We've been working closely with the Harbormaster because eelgrass restoration is a worthy cause, but it's a lot of work. As you saw in the last slide, there's divers, there's volunteers. It's very expensive, and that site up in the head of the harbor actually didn't work out. It basically we're not entirely sure, but we're fairly certain that a combination of some native species like spider crabs, as well as some of the currents there, prevented it from really taking, and nothing we planted or seeded actually succeeded there. So we're moving on to new sites, and we're also looking into other ways to, rather than restore it where it's been lost, try to preserve it where it is, which is huge. And one of the things we've been working with the Harbormaster on is eelgrass friendly moorings. She's not too keen on the design of the mooring traditionally used in other places because she's former Coast Guard and she just doesn't trust the spiral anchor with a bungee cord to the mooring ball setup. So we worked out something else with her. That's a pyramid anchor with a chain, and it leads to the bungee, a buoy, and a rope holding the chain up off and preventing the chain from scouring the bottom. Noah and I placed some PVC markers, as you can see in the photo, around the mooring of the Land and Water Council boat. And for the last 2 seasons, we were just checking on low tides and going out periodically to see if there's any scouring of the chain. Because there's hundreds and hundreds of moorings in both harbors, and they're in areas where we know from water quality data we've been collecting that the eelgrass could grow there if the chains would leave it alone. And so we're working towards a compromise with the Harbormaster on a setup of a mooring that will satisfy her concerns about it not holding up, say, during a gale, and it did during a gale back in October. So we made that point, and is going to allow people to have their boats while preserving the eelgrass in that area. And I mean, there's acres we can get back that we don't have to do anything sophisticated. We're just going to switch out mooring equipment. So we're only going to do it in areas where we have good water quality data, which is why it's so exciting to have the town and Mariah Mitchell and Charles's team, everybody sort of working on painting a really good, accurate, real-time picture of what's going on in the harbor. Otherwise, all these efforts we're doing to try to preserve and bring back areas we've lost of these eelgrass meadows, like I said, we'd be flying blind and they would be for naught. So with that was my last slide. Thank you very much.
Thank you, RJ. I think next we have Rich.
Okay, thanks everybody. I just wanted to say, just in case, because I didn't actually put it in my bio, but I do have extensive experience measuring these parameters that we're going to be talking about. I spent a lot of time at sea, mostly oceanographic stuff, but I just didn't want to make sure, I didn't assure people that I do have some experience. But the other experience I have that's relevant to this is for many years, I was a commercial fisherman on Cape Cod Bay. And that I think really is even more important because it teaches you how to relate to and depend on and revere marine ecosystem. So I carry that into the work that I'm doing here. So what I want to do just real quickly is to present some of the preliminary data from what I think is a really exciting addition to all the work that we've been in the research that everybody's been doing. But basically, last summer we launched an automated buoy, and you can see a picture of it on the right there. This has been moored, you can see, off of Brant Point at a spot that we chose primarily because, well, for lots of reasons. One, not the least of which is navigation. We needed to be sort of out of the way. That's really important, but also it's protected there. It's proximal to some healthy eelgrass beds, but also it's a very dynamic spot, as I'll show you in a minute. So there's lots of reasons that we chose that particular location to put this buoy. And while I'm at it, just so you know about the buoy a little bit, it's solar powered. You can see it there. It's about a 400-pound Lonimer foam buoy, and below that is where all the sort of the electronics are. The SONs, similar to what Emma and Tara use. Those live in those blue. They're called stilling wells. Those are the blue tubes that go down. That's where the SONs work. That's where the electronics are. Then in the middle of the buoy, you can't really see it here, but there's a data logger and some batteries and some electronics which are fed solar power. But then every 15 minutes we will take all the data that we've collected from our two SONs, temperature, nitrogen, pH, conductivity, dissolved oxygen, and chlorophyll, and it'll be transmitted to the cloud through that little antenna there. And then if you look closely, there's a little light. So if anybody's out on the water at night, you can look out to this area and you'll see that little flashing every 4 seconds, a little yellow light flashing. That lets you know that it's out there working. I go and check on it all the time. So that's the buoy out there, and it's managed by us as a team. And I really appreciate everybody's help. Christina and Janelle, there we are launching it last summer, and it was happy and collecting data. So next slide. So the place where it is, it's down there on the left. You can just kind of see where it says buoy down there. That's where it's located. And you can see this is a super dynamic spot. This is this spot and this buoy sees water from pretty much every part of all of our harbors. Incredibly dynamic spot, which is great because we get to see this huge range of data, but it's also pretty noisy. So in other words, not like noisy, but it's like there's a lot of noise in the signal. That's what I'm trying to say. And so it takes some really careful interpretation of it, because if this were animated, you'd see how the buoy is subjected to a lot of different water bodies and a lot of dynamic sort of hydrological and circular and turbulent eddies and things like that. So it takes a long time sitting with this data and looking for patterns. And that's really what the data we're collecting is really superb at, because it's continuous data. It really does reveal patterns and trends that you just don't get from spot checks. So anyway, yeah, next slide. So here's some of the data. This is coming off the Hydrosphere site. And if you look and see, this is a great example. So as you look at this, the red line is the tide, which I got from NOAA, and I superimposed it onto our data. So this is nitrate data, the blue line. But if you look, and if you sort of not squint your eyes, but just sort of look at the whole thing, you'll see that every time the tide is low, the nitrate tends to be high, and every time the tide is high, the nitrate tends to be low. This is the kind of thing that we're like seeing now. Like this is the kind of pattern that there is, and it's consistent through the whole thing. If you follow it along, you say, oh wow, these lines are sort of offset to each other. They're sort of inverse to each other. What does that mean? What is that saying? And it's saying something really important about that location and what's happening there, but it does take some interpretation. So next slide. I'll go quickly through these. Here's another one where we're seeing nitrate data for the month of pretty much the whole month of September. We didn't get a lot of rainfall, but you'll see on September 19th there, we got this spike, 2.21 inches and then 1.84 inches in 2 days between the 19th and the 21st. And then what do you see happen right after that? That blue line shoots up. Okay, so nitrate levels went up and they were affected by that major rain event. But also you see that other little rain event on the 8th, it didn't really affect it at all. And so, and then you get these spikes, which I'm still trying to figure out what they are. And there's lots of interpretations on that. But this is the kind of data we're getting. And so you can really see how rainfall affects the nutrient levels in the harbor. Okay, next slide. So we're also measuring dissolved oxygen. And so this slide, again, just sort of shows how the DO is affected by rainfall events. And this is probably, the effluents and the stormwater runoff is carrying nutrients, and bacteria love that, algae love that, and they will consume the oxygen. And so you see this corresponding drop in the dissolved oxygen, which is temporary. Another good measure of that. So next slide. I also started to superimpose other data, so other meteorological data. This is wind. I was trying to see if there was any patterns or correlations that I could see between wind and dissolved oxygen, which I could not. I'm not sure if it's important to do it or not, but I was just sort of spending time with the data and looking for trends. Next slide. pH and rainfall. Again, we can see how that big rain event in September had an impact on the pH. The pH essentially lowered. Does that make sense? Yeah. So anyway, so we can go to the next slide. Oh, so this is pH and versus tide, which is the red line. Still working on what these sorts of things might be, but it is consistent with something that we can say that's rather, it's kind of obvious. You think about our harbor, what makes it unique is that it gets an influx of what you could think of as almost continental shelf water. It's Nantucket Sound water, but it's a flush of relatively pristine water. So we get this kind of reset button twice a day on Nantucket. Most places don't get this. Where I grew up on Cape Cod Bay, they don't have the same opportunity we do because that's the mainland. Because we're on an island, it's the fact that everything that happens on Nantucket ends up in our harbor. It's an important insight that I think is going to be essential to policy. And we'll get into that in a second, but next slide. This is conductivity and rainfall. Again, this is preliminary data. I'm just looking at it, spending time with it. I see this funky lines up to there. We've still got to, we can still converse about what this means. But this is the kind of data, and these are you can just imagine the new questions that this kind of correlation can start us asking. Next slide, please. Okay, so here's a really cool one. So the big thing that we're doing, the big contribution here is our nitrate sensor. It's very hard to measure nitrogen in salt water, especially in a hostile environment like a marine environment, in a place that's not connected to land, and it has to be completely automated. But this is it. So this is from August through November, the entire nitrogen set. And you can see our minimums, maximum, and an average. But again, remember that rainfall event in September, we see that spike. That's the first red circle. So we see that happening, and that makes a lot of sense. But here's a really new cool insight that we didn't know, that by the time November rolls around, okay, it was big news when that September rain event happened and we saw the nitrate spike, right? It's like, oh no, all this nitrogen in the harbor. It did tend to mitigate itself and get back into its normal sort of cycles. But here's the big insight. We didn't know that in November, the whole harbor was consistently subjected to the same nitrogen level as happened in a major rainfall event. That's pretty important to know. That's a potent piece of data, that our harbor, by the time November rolls around, is bathing in that higher nutrient load. Why? I don't know. We need to figure this out. But previous data suggested that it might even be going down in November, and it's not. And so this is the kind of new insight that can be the basis of much better decision making. This is a quantitative sort of, I think it's a quantitative breakthrough in terms of the kind of data that we're getting. And once we get the buoy back, I'm excited to get the buoy back in the water and start to really fill out the annual cycle here. But so let's go on to the next one. So just preliminary data interpretations that I kind of came up with, that there's substantial tidal differences between the influx and the outflux of the water body. And what that's saying is that, yeah, we have this great reset button of nearly pristine water coming in every day, but while it's in the harbor, it degrades. There are significant anthropogenic effects that happen every day because the water that we put back out through this spot is more nutrient loaded, has lower values of all the things we want to be higher values on the way out. That means it is affected, and we can measure it and we can see it. That in and of itself is, I think, a potent sort of thing. Significant rainfall events have measurable impact on nutrient pH, dissolved oxygen, conductivity, while minor rainfalls don't. Okay, that's good to know. Harbor water at the Brant Point confluence returns to previous conditions rapidly after rainfall events. The buoy is an important additional platform we want to consider. So we do need to figure out where we're going to put it next year. There are some new constraints in terms of what the Harbormaster will allow, but would like to get it back in the same spot as I think the consensus. Next slide. Thanks. I did just do a little sort of informal, while I was out there every month, I would go out and do a visual transect of where you can see on there. Next slide. And what you can see, and somebody like RJ who spends a lot of time with eelgrass will really be able to see what's going on here. But I just think it's important to get a visual on the eelgrass that's near the buoy, so that we can sort of make a correlation. So yeah, that's that. Next slide. So this comes to the next other thing, this other moment that I think we're in. I grew up on a harbor very much like Nantucket Harbor, same issues. And but growing up there and becoming a commercial fisherman, you really get tuned into what the harbor's doing. You know, I used to be able to tell what the tide was even when I was somewhere else in the world. I could tell what the tide was in my home harbor. I really developed a deep relationship with it. I think that the missing link, or at least maybe one of the weak links in our chain here in being really effective, is communicating how valuable this data is and how important the water quality is and how special our harbor is. So I think a big part of what we need to be thinking about is how do we get the community on board? Because we as scientists, we are really excited about nitrogen. We're really excited about the importance of knowing this stuff, but the general public isn't. And I think if we don't have all the data in the world, tons and tons of brilliant data, will not change things unless there's a change in our hearts as well. And so I think, in fact, surprisingly, the buoy gives us an opportunity to do that because it's really exciting. And just let me tell you a really quick anecdote about this. So all through the summer, even when I wasn't on island, I'd be in New Hampshire or wherever, even on the West Coast, and I would get, I set it up so that I would get an alert on my phone every time the nitrogen went up above a certain level. So I would get these notifications. Yeah, it's kind of sucks to get notifications because we're always getting bothered by our phones. But in this case, it was like the harbor was like pinging me, you know, like, and every time I got one, wherever I was in the world, it brought me back to the buoy. And I could sort of feel and see and smell the buoy and where it was. And it forged a real connection. And so when I looked at the notification on my phone, what I also saw, if you can see this, I'll just sort of hold it up here. At the bottom there, I have a little app that shows me the tide at Nantucket Harbor, wherever I was. So when I would get the ping that the nitrogen was high, I would look at that too. And I started to notice that every time I got a high nitrogen value, it was just after low tide. It was, you know, consistently right after low tide. These are the kinds of sort of patterns that the buoy can reveal, and it can like reconnect us to the harbor in this way. When I was commercial fishing, I knew the harbor intimately. The buoy, in this really interesting way, had the same effect. I could feel the same sort of connection to the harbor that I felt when I was a commercial fisherman. And this is available to everybody. So we can use this to get people to be thinking about the harbor, thinking about how important it is and how special it is. And then the knowledgeable decisions that we're making with the data will also be wise decisions, and they'll be popular decisions, and we'll get buy-in from the community. Because if we don't get that, the community has to care about septic system design. It has to care about runoff, has to care about fertilizer use. So these are the kinds of things.
Thank you, Rich. That's great.
Sorry. Okay.
Really
Awesome.
appreciate your passion and energy around this. Tara is our last speaker. Thank you for being patient. And thank you to our audience. And take it away.
Yeah, thank you, Joanna. I appreciate it. Yes, my name's Tara, and I am the Shellfish and Aquatic Resource Manager for the town of Nantucket. I run the Shellfish hatchery down on Brant Point, and also help with the water quality and habitat arm of our department. So as everyone knows, shellfish have played a vital role in the culture of Nantucket, both economically and ecologically. Shellfish have a lot of different roles that they play, including water filtration, buffering, and helping with shore stabilization. I include a bunch of pretty pictures. So this is the inside of the hatchery. And our main role is to help with stock enhancement of Nantucket's native shellfish species. So when I came in 2009, this building didn't look this way. It was a lot more rustic as the Coast Guard boathouse. But in 2016, we were able to do a full renovation, which gave us a year-round, fully integrated facility. Everything that we have here ranges from traditional hatchery culture equipment up to some really high-tech algae bioreactors and our flow cam. So all of our staff are trained from the ground up knowing how to do things basic, but also knowing how to use this high-tech equipment as well. Our goal is, to sustain the commercial and recreational shell fisheries on Nantucket. We produce a lot of different types of shellfish depending on the needs each year. But typically we'll do bay scallops happen every year. And then we have oysters and quahogs. Last year we did ponderous arcs. This year we're getting into rib mussels. So like I said, our shellfish production is focused on enhancement, but it's also for the purpose of different restoration projects that the town might be engaging in that have a shellfish component. So as far as water quality goes in the hatchery, we have a variety of ways that we track our water quality. Emma went over some of the equipment that we have, but we're also part of the Bivalve Hatchery Health Consortium through University of Rhode Island, and it's a regional program for hatcheries to participate in. And with every spawn that we run, we are taking water samples and bacterial samples for our algae and for our shellfish and shipping them off. And then they produce a report for us so that we're able to improve our production and they're able to help solve problems regionally. Next slide, please. Okay, so as an extension of our hatchery, we do a lot of monitoring throughout Nantucket and Nantucket Harbor. This is coupled with Emma's water quality program, but all of the dots on the map that you see are our spat bags. And this program is used to monitor the spawning events that occur naturally within Nantucket Harbor and Nantucket Harbor. We're able to, when the bay scallops spawn, the larvae are in the water column for about 10 to 14 days. And when they go through metamorphosis, they generally sink down to the eelgrass and attach. But if our spat bags are out, a certain percentage will attach to the netron that is in the bags. And that's in the lower right-hand corner, you can see. And so it's a way for us to monitor spawning activity and peaks and relate it back to Emma's water quality data, which, we can tie it to temperature. Over the past 5 years, we've also been logging the new moon and the full moon each month. And in the graph down below in third bend, the little white circle is the new moon and the yellow circle is the full moon. And it's not just because of the moon phases that, the shellfish are spawning. This is also associated with larger tides and possibly higher chlorophyll levels that come in with these larger tides and trigger these shellfish to spawn. So what started out as a monitoring program for shellfish and spawning has turned into basically a spat collection program. So since 2020, we've been collecting anywhere from 75 to 100,000 spat each season. And also in 2023, we had kind of like an anomaly year where we had around 605,000. So it's a really good way for seed management and stock enhancement in tandem with our larval releases that we do through the hatchery. One of our main important monitoring programs involves our annual benthic survey. And this survey is something that has been done since 2006. It started out with a scientist at Mariah Mitchell, Peter Boyce, and we were helping him with the dives. And then when he left, there was a pause in the program, and then the town took it over in 2019, and we've been doing it ever since. But essentially, there's around 52 sites. We just added Nantucket and Turcotte last year. And there's a shellfish abundance portion where we take a look at all of the bay scallops and classify them by seed, classics, nubs, year 1 and 2, and we look at knobbed and channeled whelk. And then next slide. And then for the habitat portion of that survey, we're looking at total percent coverage, which includes eelgrass and macroalgae, We separate those out for eelgrass, branching, filamentous, codium, sheet algae, and boring sponge by percent. We're also looking at blade length and fouling scale. After we've done that, we're looking at percent bare ground. We're noting sediment characteristics, and then Rich, I'm glad you were taking pictures, because we take pictures of all the sites every year, and also underwater video. So we have all of that documented from year to year, so that we're able to look at change. And then physical parameters that we collect while we're on the boat are at each site include cloud cover, wind, sea state, the Beaufort scale, water depth, temperature, dissolved oxygen, percent saturation, and salinity. And up in the right-hand corner, we have Steve Heck, who's been part of the dives ever since he was an intern with the Natural Resources, and now he heads up the program. We use all of our own staff for divers. I think it's really important for us to be able to visually see what's going on underwater, so that we're able to connect the data and the numbers to how the habitat actually looks. So it's something that we could farm out to a dive team if we wanted, but I think since we're the ones making the management plans and making these regulations, it's really important for us to have an understanding of what's going on underwater. And so we have a lot of divers on our staff. I would say probably 80% of our staff are divers, so they're able to participate every year, so that we're able to note the changes and be consistent. Next slide, please. This is an example of what came out of the report for this year. There's a report generated every year. And this just shows for the scallop abundance, 2006 to 2010, before we instituted our restoration program with the hatchery, and then the years after. And it just shows on the base scallops per meter squared. I will note that, there is a large difference between the years, and most of that can be accounted for in the form of seed scallops that were produced. Next slide, please. Okay, so along with these annual benthic surveys, obviously, we're counting a lot of scallops and measuring them, so we know where, all the populations are in the form of.
Do you mind just thanking all of the sponsors?
Oh, sorry, I just heard somebody. So we're able to figure out how many scallops per meter squared are in different sections of the harbor. So a lot of what we do now is seed management, and most of what we do is, to prevent seed from stranding. And we're having more and more seed strandings every year because the eelgrass is going away and it's short and it doesn't have the holding capacity that it once did. So when we are doing these dive surveys, we're able to locate the seed and then go back later and pick it up and move it and spread it around. And there's lots of advantages to this. We were able to save the seed. We're also able to put it in locations where it might be growing better. We're able to thin it out to a healthy density, so there's not competition for food. And we're also able to create different spawning sanctuaries in different areas of the harbor. So it just kind of helps the hatchery out by, creating these adult populations. And then we used it a lot this year to inform our decisions for raising the bushel limit. And then also we just used this data to apply for an extension for the fishing season, which many communities haven't seen an increase in bay scallops requests for this sort of thing. So next slide, please. This is an example of the eelgrass coverage that Steve Heck generated from his report. The upper graph kind of shows the upper, lower, and mid harbor all grouped together as an average. And then down below is an example of the upper portion, which is the head of the harbor near Wauwinet. And you can see, there are slight differences between, the whole harbor average and the upper average, but you can also kind of see that the trends are fairly similar. So that's something that we're tracking and monitoring. We have information for each site, but we also have it grouped according to the lower, mid, and upper, similar to how we also report with our water quality. Next slide, please. So all of the work that we've done as far as the hatchery goes and all the money that we've put into water quality, it made sense that, you know, an eelgrass management plan was the next extension that we needed for Nantucket Harbor. This was something that we put together and approached the Great Harbor Yacht Club for their 2024 funding cycle, and they graciously decided to fund it, which we're very, very grateful for. The consultants that are hired are Urban Harbors Institute. They're doing our harbor plan update, and they also did our first shellfish management plan as well. The core work group that meets bi-monthly is NRD, Nantucket Land and Water Council, and the UMass Field Station. And, you know, we're hoping to have a draft review in June of 2025. So it's an aggressive timeline, but we're very excited to have this opportunity to kind of, you know, really focus on the habitat now. Next slide. And this is our team. And so some of the other projects that we have going on with the Brant Point Shellfish Hatchery, like I said, include the harbor plan update. We're also updating all of our town shellfish and aquaculture regulations. We have a ribbed mussel pilot project and some new restoration gear associated with that we're trying out this year. Griffin Harkins, the assistant biologist, has been working on a sugar kelp project this winter. And we're also going to be starting our second season with our myco buoy trials, which are mushroom buoys. We have a new bay scallop dredge study that's going to be happening in May, and we're also investigating collecting fishery data using an app for recreational and commercial users as well. And with that, thank you for having me.
Thank you. That is really, I think, a full presentation for everyone. I would like to thank all of the sponsors for the buoy, which include Great Harbor Yacht Club Foundation, ReMain, Sociable Weaver Foundation, Osceola Foundation, and I hope I'm not forgetting anyone else. Nope, I think that's it. All right, thank you. We do have a couple of questions before we let everyone go. I think this is one that's probably specific to RJ, which is when and where can I get one of the moorings that you were talking about, and who is installing them?
Great question. So that mooring setup is not currently commercially available. We are working with the Harbormaster, Sheila Lucy, to make that available, and then we'll be reaching out to folks to, if they're interested, help them transfer over to that style mooring. But first, we have to get approval from Sheila on which areas of the harbor she'd be comfortable converting. We don't think she's going to let us do all the moorings at once. We think it's likely going to be, maybe it'll just be Great Harbor's moorings at first, or the Nantucket Harbor Yacht Club's moorings, or maybe it'll just be the towns, or it'll likely be something like that. But we'll be reaching out through as many channels as we can as soon as those become available, because again, like, it's just an easy fix to a problem that already exists. We're just trying to get it through the powers that be, make sure everyone's comfortable with what we end up doing. So stay tuned.
Good answer. I think I'd love to put it out to the audience. If they have any questions, you can either raise your hand or put them in the Q&A, and we can take them that way. But I have a couple of questions from listening to all of your presentations that I'd like to toss out there. I'd love it if one or two of you could answer the question of what is the most important thing that we can do as citizens of Nantucket for the harbor? Does anyone want to take that one? Maybe I'll toss that to Tara.
What is the most important thing that we can do as citizens of Nantucket?
Yeah.
I think become involved and be observant of your surroundings and the changes. I mean, people don't really care about what's going on until it affects them. And so there's so many different user groups with the harbor. And I think finding ways to reach out to them so that they can connect in a way that's meaningful to them and understand the importance of what everyone's trying to do, would be the way to go. And I think as far as like all of us working together, I think is also very important, you know, to understand, you know, some of the things Rich was talking about with the interannual variations and kind of understanding what that means as a group, so that we're all on the same page and looking at all of our data together, and presenting it as one front would be important as well.
Thank you. RJ, I also have a question for you, which is, you know, as in the Waterkeeper, what do you think is the most important thing that people should know about our water quality? Like what is that?
Sort of echoing what Tara just said. Pay attention. It's this, we don't have a Charles mentioned point and non-point source pollution in the beginning of this presentation. We don't on Nantucket have a big factory that's gonna pipe stick it to the harbor that's just dumping PCBs in, which I mean that's great. Thankfully, we don't have that, but we also don't have that one villain that we can all point to and say this is the source of our water quality issues. It is really death by 10, 15,000, 20,000, 60,000, however many people you think come visit here every year cuts. And it comes down to these little things where, you know, the little bits you can do. If you're in the harbor watershed, make sure you're fertilizing properly. Make sure your septic system's up and running. These are all things that have been said during the presentation. There are little ways for you to chip in. You don't have to be the one with a cape who comes in and solves all the problems. It'd be great if somebody did. But there are little things you can do and do those little things and stay active, participate, volunteer, help us out.
Mhm.
And I think residents need to take ownership of their contribution to the nutrient problem and look at their septic systems, and look how we're going to change that loading. But the fertilizer, people need to take ownership of that issue.
Thank you. Thank you, Charles. I think the last question I would ask, and really anybody can jump in on this, is if you had a crystal ball, right? What would you say could be the best expected outcome if we look out 5 years? Anybody can jump in. I'm the optimist. I'm not saying the worst. I'm saying what's the best outcome we can expect.
I think
I'll jump. Oh, go ahead.
The town has the responsibility over the next 5 years to, under the watershed plan and that permit that's coming up, to really plan for the elimination or relocation of stormwater outfalls into the harbor and address the nutrient loading coming from septic systems and take ownership of that and enforcement to limit those nutrient inputs.
Okay. Sarah.
Oh, I was just going to say, you know, I agree with Charles. There are certainly some problem areas in the harbor, but overall, if you look at the trends, things are improving. So it would be my hope that in 5 years that things would, you know, maybe not continue. Well, hopefully they would continue to improve, but also it would be a little more stabilized. And so anything additional that we can continue as a town or as a community doing would just, you know, provide more improvement to lowering those nutrient loads, and we can tackle some of the other issues that are physical stressors causing problems in our harbor.
Rich, did you want to take a stab at that question? No. Okay. All right, well, we are, I think, at the end of our program. I want to thank everyone again for their participation tonight and your excellent presentations. I think it's really been very informative for our group that we had listening, and I look forward to doing this again, possibly a couple times a year, so we can sort of keep everyone informed on what's going on and know how much we appreciate all of you and your efforts. Thank you. If you've been listening, I'm Joanna Roche from the Marai Mitchell Association. We've had an esteemed panel of speakers, Dr. Rich Blundell, Charles Johnson, RJ Turcotte, Tara Riley, and Emma Morgan. Thanks and have a great night. All right, guys, thank you so much.